Welcome back to a new set of problems, and this lesson is about using the trapezoidal rule to find the area under a curve. It's an important subject because, as you know, there are some functions that you cannot find the area under the curve, like for example, cosine of x squared. Cosine of x squared, there is no any function whose derivative is cosine of x squared. That means that you cannot apply the first fundamental theorem to find the area. So in such a case, or in other cases, you find the area by an approximation. And the technique to approximate this area is named the trapezoidal rule. Let's go to analyze what it means, the trapezoidal rule. Let's go to derive the equation for the trapezoidal rule. The trapezoidal rule says that the area between a and b of a function f of x is approximately v minus a divided by 2n, and now comes as terms that is f of x0 one time f of x0 plus 2 times f of x1 plus 2 times f of x2 plus 2 times f of x3 plus 1 time the last one, f of xn. So let's go to derive this equation. This equation is being derived it's not difficult to derive, but I will give you the details of the derivation. First of all, the first thing that you have to know is that if you have a trapezoid, so the trapezoidal rule it says, if you have the function f of x, the black one, and you want to find the area under the curve, use trapezoid. Construct trapezoid under the area. By joining point x0, f of x0, with the point x1, f of x1. So this point is the point x0, f of x0. And this point is x1, f of x1. You join the point and you make a trapezoid. If you remember, the area of a trapezoid is the average height, f of x sub I plus 1 plus f of x sub I, the height here, the sum divided by 2 by the width is the area of the trapezoid. Indeed, the area of the trapezoid is the area of the rectangle plus the area of the triangle, where this amount, the height of the triangle, is f of x sub I plus 1 minus f of x sub I. If you make the area of the triangle plus the area of the rectangle, you will find this expression. Not difficult to find the area of a trapezoid. So because we subdivide the area under the curve into many pieces, we need to sum every piece. So let's go to make the sum to realize that this equation is a valid equation to find the area. And this function f of x can be a continuous function and can be a complicated function that maybe you don't know what is the antiderivative of the function. Indeed, I think that your calculator maybe is using the trapezoidal rule to give you an answer about the area, the definite area of a function between x equal 1 and x equal 3. Okay, this is the method. Find the area A1. A1 is f of x0 plus f of x1, f of x0, this height, plus f of x1, divided by 2 by delta x. A2, same thing. F of x2 plus f of x1 divided by 2 by delta x. f of x1 plus f of x2, the average height in the piece 2 is the area to multiply by delta x. Okay, and A3 is the same. Make the sum and you find the equation that say, make the sum and you would find the 1/2 is a common term. It's all over A1 plus A2 plus A3 is 1/2. The delta x is a common term. It will be f of x1 plus f of x0 plus f of x1 plus f of x2 plus f of x3 plus f of x4. Okay, let me correct this. Let me correct this, I'm sorry. Let's go to erase everything. Is 1/2 by delta x multiplied by delta x is b minus a divided by n, f of x0 plus f of x1 plus f of x1 again plus f of x2 plus f of x2 again plus f of x3. Now it's correct. So the area will be 1/2 v minus a delta x is v minus a divided by n. Let me now correct this. And it will be f of x0 plus 2 times f of x1, this is 2 times f of x1, plus 2 times f of x2, plus the last term, f of x3. And this is the area. So in general, when you divide, in this case, I have divided the area in 3 parts. So the general equation will be this one. This one will be the general equation. To divide in n parts, this will be the general equation. So the first problem that we are going to solve is use the trapezoidal rule to find the area under the curve x cubed ddx between x equals 0 and x equals 3. Graphically speaking, they are asking me for this area. The total area here. There is no geometry formula for triangle or rectangle that I can apply. And imagine that this equation is not integrable, that you cannot find the antiderivative of the function of x cubed. That of course you can find, and of course that you can find exactly what is the area. Let's go to apply the trapezoidal rule to this problem. So AB is 0, 2. So delta x is b minus a divided by the number that I want to divide the segment 1, 0, 2. So I want to divide in 4 parts. So delta x is 2 divided by 4. Delta x is 2 divided by 4, that is 1/2. So I have 1/2, 1, 3/2, and 2. So I have to evaluate the function f of 1/2, f of 0, f of 1/2, f of 1, f of 3/2, and f of 2. And I have to evaluate and use my trapezoidal rule to find the area that is under the curve. So let's go to find it quickly. So in this case, n equals 4, v minus a equals 2. And v minus a divided by 2n, because there are n part, delta x is 1/2, So, because there are 4 parts, v minus a divided by 2n is 1/2 of 1/2, which is 1/4. So now I will write my equation. My equation says that approximately the area is v minus a divided by 2n multiplied by 1 times f of x0, 2 times f of x1, 2 times s of f2, 2 times f of x3, 1 time f of x4. So remember, the interval is the interval from 0 to 2. The width is 2 minus 0 divided 2 minus 0 is the width, and I divide in 4 parts. So every part, delta x, will have 2 minus 0, b minus a, divided by 4 times. So it will be 2/4, that is 1/2. So the first point is the point x equals 0. Because this is delta x, and delta x is 1/2, the second point is x1, and x1 is 1/2. The third point is x2, and x2 is the point 1, because it's 1/2, plus delta x. Delta x is 1/2. And the third point is 3/2, because the previous point was 1 plus 1/2, delta x, it will be 3/2, and if you add again another 1/2, the last point will be 2. Okay, so these are the points, and I'm going to see what is f of 2, f of 3/2, f of 1, f of 1/2, and f of 0. And I'm making a trapezoid here to find the area. Whatever is the function. I don't know how is the function. So let's go to apply our equation that is written here, and let's go to find the result. The equation is that the area between 0 and 2 is approximately b minus a divided by 2n by the sum of this term, f of x0, 1 time, 2 times, 2, 2, 1. So it would be f of x0. What is the function? The function is x cubed. So x0 is the point 0. So x0 is the point 0, 1/2, 1, 3/2, and x4 is the point 2. So f of 1/2 here, f of 1, f of 3/2, f of 2, and f of 0. So what is f of 0? F of 0 is 0 cubed, is 0. What is 2 times f of x1? F of 1/2 is 1/2 cubed, plus 2 times f of x2. x2 is the point 1, 2 times 1 cubed, plus 2 times 3/2 is cubed, plus 2 plus 1 time f of x4. x4 is 2, so 2 raised to the power 3 is 8. So this term is 8, and if you use your calculator to sum, the area will be 17 divided by 4, which is 4.25. Is this area bigger than the actual area or smaller? Is bigger than the actual area. If the shape is concave like this, if the shape of the function is concave like this, when you make the trapezoidal rule, you will obtain always an area that is smaller than the actual area. To find the actual area and to compare with 4.25, you need to find the integral that in this case you can do it. You can do it. Let's go to do it quickly. The integral between 0, x equals 0 to x equal 2. the function is x cubed ddx, the integral or the area below the curve is x4 divided by 4, evaluate between 0 and 2, so it will be 2 raised to the 4 divided by 4 minus 0 raised to the 4 divided by 4, which is 0, so it will be 2 by 2 multiplied by 2 squared divided by 4. I see a 4 here, so it's 2 squared. So the area will be 2 squared. So the area is, the actual area is smaller than the actual area is smaller than the trapezoidal rule. It means that the curve is not doing like I said. The curve is doing something like this. Should be doing something like this. And now the area of the trapezoidal is bigger. Good. Okay, let's. And now we plug in numbers. So it's a question of calculation. It's a question of using your calculator. So let's go to find the area. The area will be v minus a divided by 2n is 1/4. F of 0 is f of x is x cubed. So f of 0 is 0. 2 times f of x1 is the point x1 is the point 1/2. So f of x1 is 1/2 cube. Plus 2 times f of x2, the point x2 is the point 1. So f of 1 is 1 cube. So 2 times 1 cube. 2 times 1 cube. The point x3 is 3/2. So 3/2 cube is here, 3/2 cube, 2 times. And the point f of x4 is the point 2. 2 raised to the power 3 is 8. And if you make the sum, it will be 4.25. This is the area, the approximate area using the trapezoidal rule. Of course, that you can do the exact area between 0 and 2. Let's go to do it. The exact area between 0 and 2 of x cubed ddx will be x4 divided by 4, the antiderivative, evaluate between 0 and 2. So it will be 2 raised to the 4 divided by 2 squared, that is 4, minus 0. And 2 raised to the 4 is 2 raised to the 2. And 2 raised to the 2 is exactly 4. So the area that the trapezoidal rule is giving you is bigger than the actual area. Why? Why is that? Well, if you connect the points, let's go to do it here. This is the function x cubed. The function x cubed is here. So if you connect the points, you see this is the 1 maybe, or the 1/2. This is the 1. You see that the area will be bigger than the actual area. And this will happen for all points. So that's why the approximated area using the trapezoidal rule is bigger than the actual area, that the exact area is 4. Okay, let's go to the next problem. Problem 2 is also using the trapezoidal rule, but now you have a different function. We have to find the area under the curve x multiplied by square root of x squared plus 1 between 0 and 2. What did say the trapezoidal rule? Divide the segment 0, 2, divide in 4 parts. 1, 2, 3, and 4 parts. Name the points x0, x1, x2, x3, and x4, and use the formula for the trapezoidal rule that say that the area under the curve is b minus a divided by 2n f of x0 plus 2 times f of x1 plus 2 times f of x2 plus 2 times f of x3 plus f of x4, where now b minus a is 2 minus 0, which is 2. N is 4, so v minus a divided by n is 1 half. And the v minus a divided by 2n is 1 4. So this term will be 1 4. 1 4. F of x0. x0 is the point 0. So f of x0 will be 0 plus 0 squared plus 1. This would be 0. F of x0 will be 0. Sorry. Plus 2 times f of x1. F of x1 will be x1 will be 1 half, so it will be f of 1 half. F of 1 half is 1 half multiplied by the square root of 1 half squared plus 1. 1 half multiplied by the square root of 1 half squared plus 1. 2 times. Plus 2 times f of a1. F of f1. F of a1 is 1 multiplied by 1 squared plus 1. 1 squared plus 1 is the square root of 2. By 1 is the square root of 2. So 1 square root of 2, 2 times. 2 times f of a1 plus 2 times f of 3 half plus s4 plus f of 2. F of 2 is 2 times a square root of 5. And now the sum, oh, it was here, sorry. So the sum should be like 3.45. All the problems, it involves a lot of using your calculator, so you can do also this problem. You can check, well, you can use the equations again, b minus a divided by 2n, and if you follow, the solution will be 1172. Okay? In this case, you can find the exact area between 0 and 8 by finding the antiderivative and making the change of the antiderivative function g of 8 minus g of 0. And this will give you the correct area, and the correct area is smaller in this case. It's bigger in this case because, let me think, the cubic root, the cubic root should be something like this, a positive from 0 to 8, should be something like this. So when you do the trapezoidal rule, the area will be bigger. Okay, let's go to do it. Let's go to do it to see if I'm wrong. The actual area, I'm saying that will be bigger. So the actual area will be the integral from x equals 0 to x equals 8 of x raised to the 1/3 ddx, which is x raised to the 1/3 plus 1 divided by 1/3 plus 1. So this is x raised to the 4/3 divided by 4/3 will be 3/4. And this should be evaluated between 0 and 8. So it will be 3/4, 8 raised to the power 4, the cubic root. And what is that? What is that? This is 3/4, the cubic root of the cubic root of 8 to the 4 will be around, it will be exactly 12. exactly 12. So the area using the trapezoidal rule is smaller. So it means that the curve is doing like this. This is the curve, and using the trapezoidal rule, you are doing like this. So the area under the curve of the trapezoidal rule is smaller than the actual area. Okay, good. Also, next problem is for you. It's just to apply the same thing. Approximate the area between 0 and 2 using the trapezoidal rule, and the answer that you should find is 3.2. Approximately, of course. You can do the same thing. This is interesting because you cannot find the antiderivative of cosine of x squared. And the area between 3 and 3.1, the area should be minus 0.098, meaning that there are more area, or the area between x equals 3 and x equals 3.1 is below the axis x, and you should do it and check your answer. You need to use your calculator. Same thing for this problem. The area should be 1746. Same thing for this problem. Oh, let's go to do it, this problem. In this course, we studied trigonometric function. When the function is f of x equal 1 divided by 1 plus x squared, what is the antiderivative of the function? The antiderivative of the function is arctangent. Arctangent of x is the function whose derivative is 1 divided by 1 plus x squared. So if we apply the fundamental theorem of calculus to this equation, we will find that the integral from 0 to 1, from x equals 0 to x equals 1, of 1 plus x squared is arctangent of x evaluated between x equals 0 and x equals 1. So it will be arctangent of 1 minus arctangent of 0. How I will know the value of arctangent of 1? If y is equal arctangent of 1, how I will know who is y? Well, I will know like this. I will write y equal arctangent of 1, and because I know that tangent is the inverse function of arctangent, I will apply tangent of y here to both sides of the equation, and tangent of arctangent of 1. So tangent y is 1. So now I will wonder, who is the angle y whose tangent is 1? So I will say this is y, the angle y. So this is v, this is 1, and this is a, and I know tangent of y is v divided by a, is opposite divided by adjacent. So, and tangent of y is 1. So I know that y should be 45 degrees, or pi divided by 4, because tangent of pi divided by 4 is 1. How I will find arctangent of 0? This term. I will do the same thing. I will write y equal arctangent of 0. I will apply tangent to both sides of the equation because I know that tangent of the arctangent, because they are inverse function, this will be 0. So tan of y will be 0. So I will wonder, what is y whose tangent is 0? And y is 0 because tan of 0 is 0. So y 0. Or in other words, y is arctan of 0. So arctan of 0 is 0. So the equation that is here is that this is pi divided by 4, arctan of 1 is pi divided by 4, minus arctan of 0, that is 0. But I forgot this 4, the 4. Indeed, the integral is 4 times this, 4 times this, 4 times this, and now it's pi. Now the problem is solved. Okay. Use the trapezoidal rule again and see why if f is concave downwards on the interval 0, 2, using the trapezoidal rule, would your answer be too large or too small compared with the exact? Well, you know how to answer this question. Think about it.